Today we'll see 1.9 torque. It is also known as moment of force or the turning effect of force. It is indicated by tau. This turning effect of force is nothing but amount of turning. So we are going to see the torque or turning effect of force. Let us say this is a nut. एक नट है and we want to tight this nut या इसको लूज करना है. ओके सो अगर मैन्युअली हम लोग अगर कर रहे हैं तो इट इज़ वेरी डिफ़िकल्ट टू टाइट दिस नट या लूज करना है तो इट इज़ वेरी डिफ़िकल्ट बिकॉज द मोर फोर्स इज रिक्वायर्ड. बट इंस्टेड ऑफ द मैनुअल if we use the wrench या स्पैनर यूज़ करते हैं. सो दिस इज़ द स्पैनर या wrench है. घर में आपने देखा होगा स्पैनर. Now with this spanner it is very easy to tight this nut या lose this nut. So force is applied by using this spanner. If I apply the force over here at a distance r1, okay, then this force into this r is the moment arm. So force into this radius, it will produce distance, the force into this distance r1, it will produce the torque. Say tau 1 is equal to force F into the perpendicular distance. So this is a pivoted point या fixed point है and the force is applied like this. Second, if I apply the force over here at a distance r2, so tau 2 equal to F into perpendicular distance, that is r2, perpendicular distance. So this tau 2 is greater than tau 1. Torque or amount of turning produced by this is greater than amount of turning produced by this, because the radius, the moment arm, the distance of application of force is at a larger distance. तो इससे ज़्यादा torque produce होगा, इससे कम torque produce होगा. Okay, so because of that spanner is used. अगर आप manually कर रहे हैं तो you are applying the force at a very small distance. Okay, because of that torque produce is very negligible. But if you apply the force at a larger distance, then torque produce will be larger. Torque is given by the force into the perpendicular distance. R perpendicular is the torque is given by force into the perpendicular. Suppose this is a rod. Okay, this end is pivoted, fixed. Okay, and this rod can rotate about this fixed end. Okay, so if I apply force, a force is applied at a smaller distance from this pivoted point, then a larger force is required to rotate this rod. If I apply the force at this end, then a smaller force is required to rotate this or to produce the turning effect. Because if I apply the force at this point, then torque will be larger. Torque is force into this distance. Okay, then another point we'll consider. Now I want to rotate this rod. If I apply the force like this, if force is passing through the point of rotation, then this rod will not rotate. Or if I apply the force from here, then this rod will not be rotated. इसको rotate नहीं कर सकते because the force is passing through the point of rotation. रोटेशन से पास हो रहा है तो we cannot rotate this. So let us take an example. Rod is there and this is a pivoted point, pivoted या fixed point है ये, and force is applied like this. Suppose this is the force F1 है, then this force is F2, this is the force F3, okay, this is the force F4, okay. Now we want to find out the total torque produced by these forces. So the force which is passing through the point of rotation, so this F3 is passing through point of rotation, this F4 is passing through the point of rotation. So torque produced by this force 3 and force 4 is 0 because it is passing through the point of rotation or the pivot point. Now if we want to find out the torque produced by F1 force, so this torque is nothing but whatever the distance, say this distance is R1, it is force F1 is at a distance R1, so torque produced is given by F into R1. Similarly F2 force, so F2 force has, so we have to resolve this into two components. Suppose this angle is theta, so this is F2 sine theta and this is F2 cos theta. So this F2 cos theta will not produce any torque. F2 sin theta जो है torque produce करेगा. So F2 will produce the torque which is equal to F2 sin theta into perpendicular distance. Suppose this perpendicular distance is, this force is at a distance R2. Okay, so perpendicular distance is R2. Okay, F3 will produce 0 torque, F4 will produce 0 torque. Even if you resolve this into two components, so this force is passing through the point of rotation, so it will not produce any torque. So if I increase the force, if F is increased, then torque will also increase. If I increase the point of application of force, this R को मैं increase करता हूँ, तो then also torque will increase. Now we'll see the expression of torque in terms of moment of inertia. Torque is a vector quantity. It requires both magnitude and direction. We know that torque is given by, torque is equal to force into the radius which is perpendicular. So we know that the force is given by mass into acceleration. So we'll substitute this. So instead of force I can write mass into acceleration and this perpendicular radius as it is. We know that linear acceleration is equal to r into angular acceleration. This torque is equal to mass into, this A is nothing but r alpha and this again the radius which is perpendicular one. So torque equal to m into r square alpha. So this m into r square is nothing but moment of inertia. Mass into radius square is moment of inertia. So we can write tau equal to torque, tau equal to I into alpha. So this is the relation between torque and moment of inertia. tau equal to I into alpha. Next we'll see the rotational kinetic energy. Rotational kinetic energy. We know that kinetic energy is given by half m into v square. We know the relationship between linear velocity and angular velocity. Linear velocity is equal to r into angular velocity. So we'll substitute here. V is equal to r omega. So this is half m. Instead of v square, I can write r square omega square. So this m into r square is nothing but moment of inertia. So we can write this as half I omega square. Rotational kinetic energy is equal to half I omega square. Linear kinetic energy is half mv square. Rotational kinetic energy is half I omega square. I is moment of inertia, omega is angular velocity. Now we'll revise what we have covered in this topic. So there is a linear motion and angular rotational motion, and the relation between this linear motion and angular motion. Linear displacement is given by s, angular displacement is given by theta. The relation between linear displacement and angular displacement, linear displacement is equal to r into theta. Linear velocity is v, angular velocity is omega, v is equal to r omega. Linear velocity is equal to r into angular velocity. Linear acceleration is a, angular acceleration is alpha. So linear acceleration a is equal to r into angular acceleration. If some body is there, we want to change its position. Body है, उसको हम motion में लाना चाहते हैं तो force is required. So उस body को linear motion में लाना है तो force F is used. If we want to rotate that body, rotation करना है उसको, तो that is torque. So force and torque are analogous. Linear में force use करते हैं, rotational में torque is used. Relation between this force and torque is torque equal to F into perpendicular distance, F into R. So this linear velocity कैसे निकालते हैं? Linear velocity is ds by dt. Angular velocity is d theta by dt. Acceleration, linear acceleration is dv by dt. Angular acceleration is d omega by dt. Force is mass into acceleration. Tau equal to I into alpha. Relation between torque and moment of inertia is tau equal to I into alpha. I is moment of inertia, alpha is angular acceleration. Similarly, rotational kinetic energy is given by half I omega square. Now when body is rotating and उसका kinetic energy change हो रहा है, that means there is some work done. Okay, work done is equal to change in kinetic energy. Work done equal to change in kinetic energy. Change in kinetic energy is initial kinetic energy minus final kinetic energy. Okay, so if we know the initial kinetic energy, final kinetic energy, we can find out the work done. या work done दिया है तो we can find out the change in kinetic energy. Today we'll see 1.8 angular momentum. First we'll see the linear momentum. Momentum is a vector quantity. It has both direction and magnitude. Linear momentum is given by the letter P. This is equal to the product of mass and velocity. एक object है and it is in motion. Then we can say it is in the momentum. The object is having linear momentum. Now angular momentum, it is denoted by L. It is equal to product of linear momentum and its perpendicular distance from axis of rotation. So angular momentum is written as R cross P. P is the linear momentum. So we can write this as R. Linear momentum is mass into velocity. So this we can write as M into R cross V. So angular momentum is equal to mv into r. This r is perpendicular distance, mvr. Angular momentum is equal to mvr. Now we'll see the expression of angular momentum in terms of moment of inertia. This linear velocity, this v is the linear velocity and it is written as v equal to r omega. So if I substitute v equal to r omega, so this angular momentum is equal to m v equal to r omega. So this is m r square into omega. M r square m into r square is nothing but moment of inertia. So L bar equal to, this is I and this is omega. Angular momentum is equal to I omega. Angular momentum is moment of inertia times the angular velocity. Moment of inertia times angular velocity. Angular momentum is equal to I omega. I is moment of inertia, omega is angular velocity. Now we'll see the conservation of angular momentum. If net force or net torque on the body is 0 है तो angular momentum जो है constant है. That means the angular momentum is conserved if torque is equal to 0, net torque या force is equal to 0, then the angular momentum is constant. So this omega is nothing but 2 pi n. Omega is 2 pi n. Conservation of angular momentum, the examples of this is ice skating. Ice पे skating करते, okay, and they perform different stunts. कलाकारी करते ice पे while skating. So they use this concept of conservation of angular momentum. या स्विमिंग पूल में बहुत ऊपर से छलांग लगाते हैं, okay, diving in a swimming pool, okay, तो डाइव करते समय कुछ कर्तव्यकारी दिखाते हैं. दैट इज ऑल्सो इन द कंजर्वेशन ऑफ एंगुलर मोमेंटम. या बैलेट डांस करते, बैलेट डांस इटालियन डांस है, गर्ल्स जो है बैलेट डांस करते, इटालियन डांस. सो दे विल यूज दिस कंजर्वेशन ऑफ एंगुलर मोमेंटम. जब वो हाथ फैला के डांस करते हैं तो मोमेंट ऑफ इनर्शिया ज़्यादा होता है, जब हाथ बॉडी के नज़दीक होता है तो मोमेंट ऑफ इनर्शिया जो है उसका कम होता है। या एक्रोबैट इन अ सर्कस, सर्कस में अलग अलग कलाकारी आपको देखने को मिलता है, सो दे विल यूज दिस conservation of angular momentum. So according to conservation of angular momentum, momentum is given by I into omega. So I1 omega 1 is equal to I2 omega 2. I1 omega 1 is equal to I2 omega 2. अगर moment of inertia increase हो रहा है, suppose this moment of inertia जो है increase हो रहा है, तो angular velocity जो है decrease होगा, angular velocity decrease होगा, so that इसका जो product है, product जो है इसके इतना ही रहेगा, I1 ओमेगा 1 इज इक्वल टू I2 ओमेगा 2. I2 अगर इंक्रीज हो रहा है तो ओमेगा शुड डिक्रीज. मोमेंट ऑफ इनर्शिया इंक्रीज हो रहा है तो एंगुलर वेलोसिटी जो है डिक्रीज होता है. मोमेंट ऑफ इनर्शिया अगर डिक्रीज हो रहा है, मोमेंट ऑफ इनर्शिया डिक्रीज हो रहा है तो एंगुलर वेलोसिटी क्या होगा, इंक्रीज होगा, एंगुलर वेलोसिटी विल इंक्रीज. But this I1 omega 1 is equal to I2 omega 2. This is known as conservation of angular momentum. Okay. जैसे बैलेट डांसर हैं, तो अगर वो हाथ ऐसे फैला के डांस कर रहे हैं तो इसका जो मोमेंट ऑफ इनर्शिया जो है ज़्यादा है, मोमेंट ऑफ इनर्शिया इज मोर. अगर हाथ जो है बॉडी के नज़दीक है देन मोमेंट ऑफ इनर्शिया जो है इसका कम है. तो मोमेंट ऑफ इनर्शिया कम हुआ तो एंगुलर वेलोसिटी जो है इंक्रीज हो जाता है. मोमेंट ऑफ इनर्शिया अगर इंक्रीज होता है तो एंगुलर वेलोसिटी डिक्रीज होता है. लीनियर एंड एंगुलर. Okay, we know that linear displacement is s, angular displacement is theta. Linear velocity is v, angular velocity is omega. Linear acceleration is given by a, angular acceleration is alpha. To make the object to move in a linear path, force is required. So to make the rotational motion, it is torque. In the linear mass of the object is m. This is analogous to moment of inertia in rotational motion. The relation between this s and theta, s equal to r theta, v equal to r omega, a equal to r alpha. F is given by mass into acceleration and tau equal to F into perpendicular distance r, या tau equal to I into alpha, tau equal to I into alpha. Linear kinetic energy is half mv square. Rotational kinetic energy is half I omega. Linear momentum is p, angular momentum is L. L is I omega. Rotational kinetic energy is I omega square. Okay. Angular momentum is I into omega.